Hello everybody, so today we'll talk about the system design of Bittree. So Bittree is a service where the user can issue the kind of shorter URL from his original URL, which should be wrong, typically. And when the user, not limited to him, opens the link, the shorter link, that person is redirected to the original URL. So with this short URL, this short URL is used in the Twitter, so that it looks fancy. That tweet looks much smarter and slim. Okay, that being said, I will clarify the function requirement first. So as I said, user can issue, or I should say generate our shorter URL from his original URL. And also user is redirected to the and also I will include the expiration and custom areas in the function requirement in this design. So user can optionally specify the custom alias. And also user can optionally specify the expiration. So basically the short URL looks something like bit.ly.com slash bit.ly slash some alias. But in the design, I'd like to make it possible for users to specify that custom alias part, if possible, if it's not used yet. Okay. And also user can optionally specify the expiration. This means that, let's say user specifies 1 month expiration for the short URL. In that case, after 1 month, when there is someone who clicks the short URL, the 404 not found error should be returned. Okay, so now I will talk about non-functional requirement. Okay, so let me get started with the CAP theorem. So CAP theorem is the theory which says that the system can guarantee up to 2 of 3: strong consistency, availability, and partition tolerance. And because we are designing the distributed system, the partition tolerance is a must. Otherwise, the system doesn't know how to handle the network connection, which is the connection between the nodes. So I need the partition tolerance. And that being said, consistency versus availability. So if I take the strong consistency, the system always returns the latest writer. But if it is not possible, the system doesn't return anything, just returns error status. But if I take the availability, what happens is that the system tries to return the latest data, but if it is not possible, it just returns the bit outdated data. Yeah, so it keeps returning some data, but it may be outdated. So in the case of Bittree, I can say if I take the strong consistency, when there is a short URL created, if there is a user who accesses it, it's always definitely redirected to the original URL a moment after the URL is created. But if I take the availability, it is possible that if it cannot guarantee the, okay, so if I take the availability, the system always redirects the user, but after maybe a few seconds after the URL is generated, it may not redirect the user with that URL, short URL. So, and one thing I have to notice, if the system cannot guarantee the strong consistency, the system fails for all the URL redirect, because maybe there is a new URL which is created after the moment, so system cannot return outlet status, so it stops returning anything, which means that the URLs already generated may be affected too. So considering this from the user, experience perspective, definitely reliability takes this availability. So it totally finds that after the URL is generated for a few seconds, the users who accesses the URL may not be redirected, but I accept that, but instead I make sure that the generated URL always redirects the user. Yeah. Okay, so next I will talk about the latency. So we have two APIs, generating the short URL and redirecting the URL. So generate URL. I would set the number 500 millisecond here. Yeah. So I just want to mention that redirect, this is extra 500 millisecond. Obviously, if the original URL takes wrong, if it has a huge latency, we cannot guarantee how many seconds it will take for user to view the original URL. So this is redirect 500 millisecond is just a kind of extra, portion of latency. Okay, and also I will talk about the two things which are unique to B-tree. So firstly, I'd like to make sure that the URL, generated short URL, is as short as possible. And also, I'd like to make sure that short and generated URL is random. So the first one, this is obviously from the user experience. User would like to get the shorter URL, so they use B-tree. So it's quite natural to think that we should make the URL as short as possible. And for this one, random URL. So this is a kind of, things that I don't want users to find the other URL by tracking I don't want users to find other URLs so easily. Like let's say URL is generated like /1, /2, /3, then he can take a look at URLs generated one by one. So it totally depends, but may not be good in terms of the security, because at least the user can know there is someone who wanted to generate that URL so easily. So I would try to make it random, but of course these two are a kind of trade-off. So if we'd like to make the URL shorter and shorter, it means that it's more likely that the user can randomly access the path URL and find the existing one. So they're trade-off, but I don't discuss the trade-off between them maybe, but I hopefully I'd like to meet both of them. Okay, and I will talk about the scalability. So I'd like to support 1 billion users and 10 million daily active, 1 billion URLs, and I want to support 10 million daily active users. 100 million daily active users. Okay. Okay, so I will talk about core entities. So core entities are like the database table names. So, or I can say like the models. So I need here user and also URL. For now, I separate the original URL and short URL. Okay, so these are core entities. And now I will talk about API design. So firstly, I will list the names of APIs. So obviously from the first functional requirement, I need the generate URL API. And also from the second, function requirement, we need the actual short URL, or I should say redirect URL API. Yeah. So in detail, I can say I use the post method, and this is the path. And the user has to specify the original URL and custom alias, optionally, and also expiration. This is also optional. Yeah. And for this API, and actually for the second API too, I don't add the authentication. So this service is open to anyone who'd like to generate the URL, short URL, because obviously, for example, the Twitter, in case of Twitter, my understanding is the URL is generated without its authentication for user who makes the tweet. Okay, so this should return 200 status and short URL. Okay. So first redirect URL. So it looks something like this. So this redirects the user to the original URL. Okay. So I think there is the discussion like if I should support the query parameter here. So of course we can support it. It's not so difficult. I just have to copy the parameter added here when redirecting the user to the original URL. So yeah, it's possible that the user specifies the parameters as the query parameter. And some discussion I'd like to make here is there are two types of redirect status. So 301 is used as the permanent redirect. And 302 is temporary redirect, or I should say temporary moved. So for 301, this is typically used when the URL or maybe website is used completely and it never comes back. So with this, the browser caches the redirect URL and the browser keep using the original, redirected URL. So when user tries to open the, so firstly, when user is redirected by 301, browser kind of caches the result. And next time when user opens the website, browser doesn't access the original, URL, but immediately opens the redirected URL. But for 302, this is, as the name suggests, this is temporary. So basically, typically, header specifies the cache control or I should say expire until, I forgot, but some timestamp which specifies until when some website is moved. So with that, the browser can cache the result, but there is a cache once that expiration has come, and when user opens the website, it opens the original URL. Yeah. So say a difference between permanently removed and temporarily removed. So in our case, I would go with the 302 because of two reasons. So number one, we specify the expiration. So with that, I would say I don't want the browser to catch the result. So I would go with the 302. The second reason is I'd like to correct the metrics. I'd like to make sure that the user accessed the original URL and then redirected to the, destination URL. So yeah, we wanna correct the metrics and have the control on the redirection. So I would choose the temporary removed as the redirect status. Okay, so I will talk about the high-level design. So there are two types of users. Number one, URL generator user, and number two, accessor user. Of course, they can be the same person, but for convenience, I separate them. And for this design, I'll go with I use the microservice architecture. So the reason is, first, I'd like to make the system fault tolerant. So for example, when, let's say, the user tweets the generated URL, and that person is the kind of celebrity, like Taylor Swift, and the link is immediately clicked by so many followers, maybe in the Instagram or maybe in the Twitter, and there is a spike of, redirection. So even with that, I'd like to make sure that the URL generation service is not affected, and to make sure of that, I separate the microservices and make sure that fault tolerant is guaranteed. So I would say here we need generation service. So when generator user makes a request, like, what is it? Generate URL request, it is routed into the URL generation service. So this API gateway does the authentication and routing, and yeah. Oh no, in the case we don't use the authentication. So typically this does the routing and maybe some rate limiting. Okay. And now this URL is generated and stored in the primary DB. So I use PostgreSQL here. This is only because this is the industry standard. If there is a specific requirement here, I would switch it to other database. So this URL generation service firstly creates the mapping, or I should say original, this URL service creates the alias and record it in the database. So I guess URL mapping. So and also we need expires at. So in the case, user specifies the expiration timestamp in the request. Okay. So now I've met the first function requirement and also third function requirement. So custom alias should be possible to be specified. Yeah. We just have to save the alias specified by the user. But one thing I have to take care is about the collision. So I'd like to make sure that there isn't any collision between the alias, obviously. So I put the unique constraint here. So with this, in the database level, the uniqueness of the alias is supported. Yeah. Okay. So now I will talk about the second function requirement, so which corresponds to this API. So the request is made from the user, and as I said, I separate the service because they have the different access patterns. So user makes the request. Oh, of course, these two can be in the kind of same GitHub repository. The important thing is to separate the deployment and the role of the servers, physical servers. So actually they can be in the same, logical code base. Yeah, in this case. So what it does is accesses this primary database, and this fetches the record which corresponds to the alias in the path. So we have to look up the data from this alias, so I put the index here. So with this, the record can be found in login time. And once the data is fetched, this URL redirect service confirms the expiration. So if the expiration is null or expired at is before or same to the, equal to the current timestamp, this URL redirect service returns the 301 status. Otherwise, they should return 404, not found. Okay, so that's what happens with this service and API. Good. Okay, now I've met the second function requirement. Nice. Okay, so that means, sorry, this is 300. Okay, so that being said, I finished my today's listening design practice. So tomorrow I will talk about these three non-function requirements. How I can make the URL short and random, and also how I can scale this system for many users. Okay, thank you for watching. Bye.